coefficient of static friction and kinetic friction. Now, to understand these two coefficients, let us perform an experiment. Suppose this is the table on which a block is kept. Now this is tied with a string and passes over a pulley here and carries a hanger at its free end. Now what are the force acting on this block here? Say one is the weight of this block, that is the gravitational force mg, that is weight. This is the normal reaction R. This is the applied force, that is, suppose here the force applied on it is, suppose it is m0g, then this is the force acting on it, so therefore the frictional force will act along opposite direction. Now we will increase load on the hanger till the block comes in such a position where it about to move. So we can say that the static frictional force, which is in this direction, has reached to its maximum value. So here, from the condition of equilibrium, weight of this block is equal to the reaction, and the force applied on the hanger, see this is m0 into g, is equal to the maximum value of static frictional force. Now again we increase load on this block. Let us put some additional weight here on the block. Now this weight, which was m0g, is not sufficient to make it move. Therefore, suppose let us add weight mass on this hanger, let it be m dash. When m dash put on this hanger, then the block attains this limiting value, means where it is about to move. So here the weight of this block also increased, so this weight is w dash. The normal reaction given by the surface of the table on the block is r dash. So therefore, since this has increased, so therefore the frictional force is also increasing along with the application of this. So let it be fs dash. So again, similar to this equation, we get w dash equal to r dash and m dash g equal to f dash s. Now from the experimental values, we find that w dash by w equal to, this is m dash g by m0g. So means these two weights ratio is equal to the ratio of these two weights. So therefore we conclude that r dash by r, the ratio of normal reactions, is equal to the same of ratio of frictional force. So we can conclude that frictional force, this type of relationship holds good when frictional force is proportional to normal reaction. So therefore we write frictional force, we can replace this proportionality sign by equal and some constant. This constant of proportionality is called coefficient of static friction. Thus coefficient of static friction can be defined as ratio of maximum value of static frictional force to the normal reaction. Now once the block sets into motion, then similar way we can define that the kinetic frictional force, as we know that the frictional force decreases a bit, so this kinetic frictional force is proportional to the normal reaction. Let it be F is for Fk is proportional to normal reaction, so therefore Fk will be equal to constant of proportionality mu k r. This mu k, this is called the coefficient of kinetic friction. So coefficient of kinetic friction can be defined as ratio of kinetic friction to the normal reaction.